So the next main thing that we need to pay attention to is that really what ends up happening is, like, when we drew these triangles, we got these we got these ordered pairs. The way that we got them was the side lengths of the triangle. So notice that if this was actually, the x direction was negative or square root of 3 over 2 and 1/2, and then this was 30 degrees in a triangle. If we took, and this is 1, my value is 1, if we took the sine of this, sine of 30, its opposite over adjacent, that's SOHCAHTOA, we would get sine of 30 as 1/2 over 1. Well, 1/2, anything over 1 is itself, so it's just 1/2. And so the sine of 30 ends up being just the y part of the coordinate. So that has some implications. It means basically this, that whatever angle you're at, cosine of theta is equal to your x value of your ordered pair. Sine of theta is equal to your y value of your ordered pair. What about tangent? Tangent, if you look, ends up being a ratio of the two, because this is opposite and this is adjacent. So I have like a double-decker fraction kind of. So this is 1/2 over square root of 3 over 2. And this creates, as if this was 30 degrees. If I use 30. And this is kind of a mess. You would change this to multiplication and multiply by the reciprocal, 1/2 times 2 over square root of 3. Or you could do a little trick, outsides over insides, which is fun. You go 1 times 2 on the top, you go 2 and square root of 3. We don't like this. We're not supposed to. 2's cancel. We're supposed to fix it by rationalizing the denominator. So in order to do that, you would multiply by square root of 3 over square root of 3. This ends up getting a square root of 9 on the bottom, or just a 3. And the top is square root of 3. So you end up getting this for tangent. Tangent's the ugly one. Cosine, so if I was doing 30 degrees again, cosine is just the x value, so that's just square root of 3 over 2. Sine is just the y value, if this were 30 degrees, and it's just 1/2. So the only other messy one's tangent. Now, one last thing is that we're not just finding the 3 trig values. We're finding 6, because there are also secant, cosecant, and cotangent. So we should be able to calculate all of these as well, and it's really not that bad. It's just the reciprocal of the other ones. So secant and cosine are related, and if cosine of 30 is square root of 3 over 2, then this is 2 over square root of 3, and we'll fix that in a second. Cosecant is related to sine, and it's just the reciprocal, so that would be 2 over 1. Cotangent is the reciprocal tangent, and so we just flip it, and I would go back to this part, because I don't want to do 3 over. I don't want to flip this over and go 3 over square root of 3 and then have to do that whole mess I just did right here, rationalizing the denominator. I can go straight to right here and say this is it's now square root of 3 over 1, and we can simplify all of these. This one tends to be the ugly one this time. You times it by square root of 3 square root of 3, because to rationalize the denominator, get rid of that square root on the bottom. You have 2 root 3 over 3. 2 is just done. 2 over 1 is just 2, and this one's just square root of 3. So we've now figured out all 3 trig functions. Cosine of 30 was 3 over 2. Sine of 30 was 1/2, and tangent of 30 equals that one. Used to using the unit circle, because creating it's hard, but using it's actually not that bad. So imagine we wanted to do sine of negative 90 degrees, and like once you get the unit circle down, you kind of don't even. It can go pretty. You can figure it out pretty quickly. So let's just reference it here. No pun. Unit circle is right here, and we wanted negative 90. So negative 90 is going to be, remember, this is clockwise direction now, 90 degrees down, kind of like the same as 270. So let's just figure out a way to handle negative degrees right away. So first of all, if it's negative, I mean, I don't want to have to think of everything backwards as well. Let's just keep it easy. This is where coterminal angles come in. If I don't want a negative degree, all I really have to do is find the exact same spot at that where that would be on the unit circle, but that's a positive degree measurement. So really, I'm just gonna add 360 to this because it's coterminal then. So if I added 360 to 90, this is going to turn out to be 270. So sine of 270 degrees is the same as sine of negative 90. And 270, we could look back at the unit circle and see that it's this ordered pair, 0, -1. And sine is always referring to the y value. So really, we're just picking up the y value at that spot, which is -1. And you're done. We did it. So this thing is equal to -1 as well. Cotangent of 270. So now this gets a little uglier because we're talking about cotangent, not tangent. So it's helpful to figure out what tangent would be. And remember, tangent theta is y over x. And therefore, cotangent is of theta is x over y. So at 270, x over y in this case. And so that's 0 over -1, which is just 0. Nothing wrong with that. 0 here divided by -1, and you just get 0. And then you get something really ugly like this. Cosine of -1620. Suffice it to say, I'm not messing around with that angle, but I do need to know where that is on the unit circle. So just take 1620 and start adding 360 to it as many times as you need to. So for instance, I know that 360 times 3 is 1080, let's say. So I know this isn't going to be enough, but just for the sake of taking an experiment, I'm adding 1080 to it. That's 3 full rotations. So 360, 360, and 360. I add that to it, and I'm still negative. I'm still -540. Well, that's no good. So add another 360, and then I'm at -180. Okay, it's still not good. I'm still negative. So add another 360. And you get +180. So really, all of this mess is just needless. We just figured out that -1620 on the unit circle, instead of going like, negative tons of loops and then ending at one spot, we could have just also gone right there in the counterclockwise direction. So we're at 180. Cosine of 180 is the same as what this is. And cosine is the x value. Sine is the y, cosine is the x. So the x value at 180, just look at the unit circle. X value 180 is -1. So this is just -1. Okay. And then there's another type of example. So these are all good ones. What if we're going to find all 6? So I'll write it down here. We're going to find all 6 trig ratios for, let's do 300 degrees. So that means that we need to know what sine of 300 is, cosine of 300, tangent of 300, cosecant of 300, secant of 300, and cotangent of 300. So all we would need to do is go back to the unit circle and figure out what the ordered pair is for the sine and cosine, because sine is just y, cosine is just x. So those ones are the easy ones. 300 down here. Sine is y, negative square root 3 over 2. And cosine is, the x value is 1/2. So 300 is negative square root of 3 over 2. Cosine is 1/2. Those are the freebies. Tangent's a little uglier. It's y over x. So this is negative square root of 3 over 2 over 1/2. You can do outsides over insides. We're going to get negative 2 root 3 over 2. And your 2's are going to cancel. Still have a negative. So this is actually equal to negative root 3. Nice thing about these 1/2 is that when you take the reciprocal trig function, or secant, then this is just 2, or 2 over 1. This one gets a little uglier. Negative 2 over square root of 3. And just like before, we got to handle this. We're going to multiply this by square root of 3 over square root of 3. And it's just going to rationalize the denominator. It's going to turn that into not a radical. And so we end up with negative 2 root 3 over 3. And then secant we did. Cotangent. It's just the reciprocal of tangent. So I could take this bottom one, say, well, it's 1 over negative root 3. And we can't mess with that business. Or rather, we have to mess with that business. We have to change it. And so multiplying by rationalizing the denominator again, you can end up with negative root 3 over 3. I just put the negative to the top. Bottom's turned into square root of 9, which is just 3. Alright, I hope this video helped.